2. Next step.
Sir, screen is not visible.
You didn't see the screen?
No, sir.
Just a minute. Let me represent the screen. Now? Wait a minute, it is presenting. Now can you see?
Yes, sir.
Oh.
Yes, sir.
Now if you differentiate this with respect to x on both the sides, so first x differential of x is 1, differential of y is dy by dx, and derivative of tan inverse y is 1 upon 1 plus y square will come. Y square into, again you will get dy by dx. Okay. Now if I bring all the dy by dx terms on the one side to the RHS, so I'll get 1 equals to, and I'll take dy upon dx common at a time. So you will end with, I think, 1, not 1. Here fraction will come. 1 upon 1 plus y square will come. So then you'll get minus 1. Because dy by dx will come this side as minus sign. I have taken dy by dx, so 1 will be left out. If you want, you can take again common, LCM and the RHS. Sorry. If I take LCM in the RHS, dy by dx also will remain same. So what will be the LCM? The denominator is going to be the LCM. Let me put the bracket. And your LCM is 1 upon 1 plus y square will come as the LCM. So in the numerator you will get 1 minus of 1 plus y square. So that you can write minus 1 minus y square. After taking the LCM, then I multiply the numerator with the negative sign. I hope this step is you can understand easily. Now here 1 and minus 1 will get cancelled. And what you do is, next step, bring this 1 plus y square to the left hand side is equals to, now what you left out, dy by dx into y square, because plus 1 minus 1 both will get cancelled. And this denominator I am sending to the right hand side. So 1 into 1 plus y square will be 1 plus y square. Here only minus y square and dy by dx will be left out. So you have a minus y square dy upon dx. What exactly you have to prove in the answer? Y square. I think we got the answer. Just bring this term to the right hand side, this negative term, minus y square dy by dx. If I bring the right hand side, you will get on the plus sign. It will become a plus sign. Then plus y square plus 1 will come, right? Control C. If you want, you can paste here. It has control V. Plus 1 is equals to 0. It is directly only, na? Which step you made difficult?
Second.
Taking the LCM. Yeah, maybe you made the mistake here. Minus sign is there. When you take the LCM, this each and every term will multiply with the minus sign. Generally, students make the mistake. Here they keep minus 1, and here they keep plus y.
Above 1.
This one.
Yes, sir.
You bring this dy by dx to the right hand side. It will become minus dy by dx. Then you can take dy by dx common from both the terms. If you want, I'll show you one step here. This will remain as this. Then minus dy by dx will come. Instead of equal sign here, let me put hyphen, implies. Here you'll get 1 is equals to. So from this step to this step, I have only one thing. This plus dy by dx, I brought it to the right hand side. It will become minus dy by dx. Now from in the RHS side, you can take dy by dx common from both the terms. So that's what I had done. I had taken dy by dx common. So here you left out 1 upon 1 plus y square. And here if I take dy by dx, you left with minus 1. So that is the thing we have to do.
Yes,
Okay.
sir.
Okay. Anyone else has any doubts in 9.2 exercise? Anushka? Sudarshan? No doubts. Okay. Then we'll move to the next topic. See, till now, in the first exercise, we found order and degree of the differential equation. In the second exercise, the differential equation is given as well as your solution is also given. Just we check whether the given thing is a solution of the given differential equation or not. Now we are going to the next process. Formation of a differential equation whose general solution is given. If the solutions are given, how do we get the corresponding differential equation? This is a little bit a reverse process. Okay, so let's see how we are going to solve such a differential equation. What I can do here. For example, if I take the example 5, from a differential equation representing the family of curves y equals to a sine of x plus b, where a and b are arbitrary constant. So let me take y equals to a sine, example 5. Let me insert the equation. Y equals to a sine, what is given, x plus b, a sine x plus b. So this is our solution. General solution is given. What is the corresponding differential equation with respect to this solution set? If this is the general, they said a and b are two arbitrary constants and x and y are two variables. Now here it is clear, as many as you have arbitrary constants, that many times I have to differentiate the given solution. Here you have two a and b are two arbitrary constants. So 2 times I have to differentiate. So let me do the first time differentiation. And first time differentiation is dy upon dx. That's what I get, equals to a is a constant. So nothing to bother about the constant. Derivative of sine x plus b. Derivative of sine x plus b is
Cos x
cos,
plus b.
right, cos x plus b into derivative of x plus b. Derivative of x plus b is derivative of x is 1 and plus derivative of b is 0. So nothing to bother about. Now second time I do the derivation, because there are two arbitrary constants, so we have to do twice differential equation. So second time if I do differentiation, I get d square y upon d x square. D square y by dx square you will get, which is equals to a into, now derivative of cos of x plus
Minus
b,
sine x plus b.
minus sine x plus b perfect, into derivative of x plus b again will come. Derivative of x plus b is 1 only, so we no need to write it. So this same thing you can write, this equals to finally minus a sine x plus b. Just I am bringing the minus sign ahead, which is equals to, just look at this number, a sine x plus b. This is nothing but y, because y is given a sine x plus b. So in place of a sine x plus b, I can replace the answer as y. So you have minus sign, so minus y. You have d square y by dx square equals to minus y, and hence final answer is going to be d square y by dx square and plus y is equals to 0. So this is the corresponding differential equation with respect to the given general solution, that is y equals to a sine x plus b. Okay. Now, as I said, I think one of the questions we discussed, this is uh, the general solution. So hence I got the respective differential equation is this one. But there might be some more differential equations, general solutions, where my answer, the respective differential equation can be the same. Okay. It's not that one particular equation, if this is the differential equation, and this cannot be the differential equation for any other equation. No. There might be some solutions. Here I have one solution. There might be some more solution which end up with the same differential equation. That can be possibilities there. Okay. With respect to, because that's what we say, with respect to one differential equation, you can have multiple solutions. That's what we mean to say. The solutions of a given respective differential equation need not be the same. Okay, this explanation is clear. How to get them. Now, one more thing you have to understand. If you observe the differential equation with respect to the given solution, in the differential equation, you never will have the arbitrary constants. If arbitrary constants are there, then your solution is going to be wrong. See here, A and B are both the arbitrary solution which presents in the solution, but in the differential equation, we don't have. Those arbitrary constants I have to remove anyhow. Your final differential equation is in terms of d squared, d cube, or d to the power of 4, or in terms of y, but it cannot be in terms of arbitrary constants. Okay, so we'll move to the next example. Yeah. Here again, form the differential equation representing the family of ellipses having foci on x-axis and center at the origin. Anyone remember the equation of the ellipse with foci on the x-axis? This is the graph if you want to see. Now, where is the word form a differential equation representing family of the ellipses? What do you mean by family of the ellipses? Here you can see first circle, first ellipse, second ellipse, then third ellipse, then it can come fourth ellipse. For all these ellipses, the differential equation is going to be the same. Okay, it is going to be the same. So anyone remember what is the in class 11th we studied? See in
X square by a square plus y square by b square equals to 1.
yes, x square by a square plus y square by b square equals to 1. That is the family of differential equation of ellipses whose foci is at on the x-axis and centered origin. Now, what I suggest to you is when you are solving this differential equation chapter, please go through the chapter ellipse, hyperbola, parabola, and one coordinate that circle chapter we studied. The center is at the origin, then center is on the x-axis and touches the all those topics. If you remember, we already studied in 11. So those topics you have to, because in the exam they give the question like this only: form a differential equation representing the family of ellipses having the foci on x-axis and center at the origin. No graph will be given and no equation will be given. So you have to understand what equation it can be. So as Sugandh said, what is this example? Example 6. So family of the ellipses are represented by the given condition is x square by a square. Let me represent here x square by a square plus y square by b square. So this will be, let me insert this is y square upon b square will come b square is equals to 1. So this is the ellipse which satisfies the given solution, given condition. Foci on the x-axis, center at the origin. Now when I differentiate this with respect to, there are two arbitrary constants, A and B. So that means again you have to do twice differentiation. So let me see what I get first differentiation. I'll get 2x upon, because definition of x square is 2x upon a square will come. Now similarly, if I differentiate y square by b square, again fractional again, definition of y square is 2y dy by dx, and the denominator of b square will come. Here I'll write into dy upon dx, which is equals to, I think you will get a differentiation of 1 is 0. Now what I do is, next step is, I'll simplify this step before I go to the second derivative, so that my calculation becomes easier. So what you can do is keep dy upon dx in LHS only. Now send the other terms to the right hand side. First, this 2x by a square will go in the RHS as minus 2x upon a square. Now this 2y upon, okay, if you want, let me put this step 1 here so that no confusion with the, let me do step by step. So what you have, this you kept here, it is. Now these steps will remain as it is in the next one. Now what comes as multiplication? Now this 2y upon b square will go to the right hand side, and it will go as b square upon 2y. I think everybody agree with this. This is b square, because it will go as a reciprocal when I transpose to the other side of the equality, and denominator it will come as 2y. Okay, now you can save 2 will get cancelled. Then you have minus of fraction, let me put. Here you have x b square, x into b square upon, sorry, it is b square upon what you have in the denominator, you have a square into y. A square into y. If you want further simplification, you can insert one more step here by keeping all the constant terms at one place, that is fraction. I'll put here b square upon a square, b square upon, here you have a square into what you have, x upon y, so that my differentiation will become easy and we don't get confused how to differentiate. Now finally you have as dy by dx equals to minus b square upon a square into x upon y. Now I'll go for the second differentiation. What do you get in the second differentiation? Let me copy this term, easy for me to solve. So if I do the second differentiation, you'll get d square y by dx square is equals to, this constant term will remain as it is, control C, control V, this constant term will remain as it is. Now here I'll insert the bracket. You have to derivative x upon y. So then I have to apply u upon v formula. What is u upon v formula? V into derivative of u minus u into derivative of v. What do you get derivative of v? Derivative of v is dy by dx, dy upon dx upon v square. V square means y square will come. That is the formula is correct. U by v, v derivative of u minus u derivative of v upon v square or minus v square.
So this is quotient rule, no?
Sorry, quotient form, u upon v, x upon, yeah, u upon v derivative.
Yes, so v square.
Sure, no, it's not minus v square. Yeah, I think it's v square is coming. Acha, one more thing this way they have done. Okay. Now we have to simplify this term. Let's see how do you simplify it. What I do is, because I cannot say, because still this answer includes b square upon a square value. So I cannot say this is the final answer. So what I do is I have to eliminate that minus b square upon a square term, at least b square upon a square. Now what I do is, can I send this y square to the RHS sign? Sorry, LHS sign. So it will come as d square y by dx square into this y square will come to the RS sign. So I'll keep y square here, which is equals to minus b square upon a square will remain as is, multiply by. Now what you left out in the bracket, I left out y minus x dy by dx. So let me insert the bracket. There is nothing to simplify here, just as it is you y minus x dy by dx. What is the difference we have done here is just this denominator y square, I send it to the LHS side, so it will go as multiplication. Now one more change here I do. In place of this b square upon a square, what can I replace? I'll call this as equation number 1. Just see the equation number 1 and tell me what can I replace with b square by a square. In equation number you have dy by dx equals to minus b square upon a square into x upon y. So in place of this minus b square by a square, can I write dy by dx into y upon x? Yes or no?
Yes, sir.
So as for everyone, so this minus b square by a square, I'll replace it as dy by dx into, if you want multiplication symbol again, and this x upon y, if I send it that side, it will become y upon x. Y upon x. Now see the solution. There is no a, b terms, right? So that's why what you can, now a and b, everything is removed. You can simplify this one in the proper way. So here you can keep it as d square y by dx square into y square is equals to, what simplification you can do is, you can open up the bracket. If I open up the bracket, you multiply y into y is y square upon x. So first term, if I open up the bracket, I'll get it as y square. You'll get y square upon x into dy by dx minus, in the second bracket, what you get, this y upon x into x. So x and x will get cancelled. You left with only y. Bracket, and then show you what will be left. Then you left out with dy upon dx whole square, because already have one dy by dx is multiplying with another dy by dx, so it will become dy by dx whole square. So finally you can keep all the terms at one place, like in the standard form. Generally y square will come, y square into d square y by dx square. Oh, yeah, y square into dy by dx square. Then I'll bring this term to the right hand side. So minus will become plus y dy by dx whole square. Then this term will come to the LHS with minus is equals to 0. So that's the final answer. Understood? Anyone has doubt? Yes, students? Yes or no? No replies, no answers.
Yes, sir.
Okay.
Yes, sir.
So they might have done the one more simplest way, final answer. They are taking the LCM with x, so that x y square d square y by dx square plus x y dy by dx whole square minus y square dy by dx. Okay. So this, you got the final answer. Maybe you can see their answer. There is no y square term because what they have done is they have taken y. Here also y is there. Here also y is there. Here also y is there. So they have taken one y common. You can leave the answer here itself, no problem. No need to further simplify. Now we have like this one more question you have. Form the differential equation of the family of circles touching the x-axis at origin. Okay, so this is the graph of equation of family of circle means all those circles which have center at the y-axis and touching the origin. The circles are touching the origin. So if you remember I'll show you. This is example 7. So touching the y-axis and center on the y-axis touching the circle at origin. For example, if I take this circle center at this point, okay, I think we cannot edit the PDF here. At this point, for the first circle, if I take this one, it is touching. If I take this one, I can say this is the distance of the point, which is nothing but the radius. So the point on the y-axis is 0, comma a. So we can say point on the y-axis is 0, comma a. This is the point on the y-axis. And what will be the radius for such circle? Because center is at the distance of a from the origin. So then the radius also will become a only. So if I know the center and radius, we already studied how to find the solution, equation of the circle. If anyone remember, general equation of a circle is x minus x1 whole square plus y minus y1 whole square equals to r square. That is the general, or you can say x minus a whole square plus y minus b whole square equals to r square. That is the general equation of a circle. Plus, anyone remember? No? General equation of a circle. Just revise that chapter once, okay? So that easy. This chapter will become easier. Equals to r square. This is the general equation of a circle. Sorry, this is b. If the center of the circle is at a comma b and if radius is r, then the general equation of a circle is x minus a whole square plus y minus b whole square equals to r square. Now center is on the y-axis. If y-axis is on the center, then x value will always be 0. And the circle is also touches the x-axis. Sorry, circle also touches the origin. So in that case, radius and the distance of the center will remain same. Now if I substitute these things in the general solution, let me copy and paste the same. Now here x value is 0, so it will become x minus 0 whole square and y minus b whole square is equals to r value is a. So when I expand, or no need to expand this one, if I simplify the first one, x minus 0 whole square, you can write directly it as x square only. X square plus y minus b whole square. Why I'm putting y minus b? I think this should be y minus a. Because my center is 0, comma a, so it is y minus a whole square. Now here you can see we have only one variable, which is a. Okay, so that means I have to differentiate only once. So you may call it this as equation number 1. There is only one arbitrary constant, that is a. So differentiation will take place only one. Let me see what you can. Differentiation of x square is 2x plus differentiation of theta square is 2 into theta into differentiation of theta. Derivative of y minus a is dy by dx, which is equals to a square is a constant term, its derivative is going to be 0. Now I can further simplify it. You can take 2 common and send it that side. It is going to be 0. So you have here as y minus a into dy by dx. Sorry. Yeah. Y minus a into dy by dx is equals to minus x. Okay. Got it? Y minus a into dy by dx equals to minus x. Now what you can do is you can take from equation you may be. Now how can I remove this dy by dx value from the given equation? If you want further step, I'll do dy by dx and dy by dx is equals to minus, you get x upon if I just a minute, if I remove here, still I have which equation I can substitute this so that if I get y minus a value here, not this way, just let me rewrite the step. Here you can write y minus a is equals to minus x into, here dy by dx, if I transfer this side, that is going to be dx upon dy. Okay. But still my a value is not going to eliminate, right? Or you can substitute this a value. Just hold on, let us check where we can substitute. If I substitute y minus a here, still your a will be left out. This value. Anyone is getting the idea?
Sir,
Yes.
आफ्टर दैट इक्वेशन 1 इन a स्क्वायर का जो डिफरेंशिएशन किया वहाँ पे नहीं होगा, वो जीरो क्यों हुआ सर वहाँ पे? आर्बिट्ररी कांस्टेंट,
It's a constant, no? So derivative of constant will be 0 only. A is a constant. So arbitrary constant derivative will be 0. Only the variable derivative we can do. Just a minute. 2x plus 2 into y minus a. And I get this y minus a value is this one. From here we cannot get x value. If I put this one, then everything will get cancelled. Just let me check where we have done the mistake. 2ay. They differentiate, expanded this one first. This way we are struggling because anywhere you substitute, my a is not eliminating. So instead of this test, That means just expand this term. Instead of equation 1, you expand with a minus b whole square formula and see what do you get. X square plus this will get as a minus b whole square, that is y square. Then you get plus a square. Then you'll get minus 2ab is equals to a square. Now what happens here is a square will get cancelled in both the directions. Then you left with x square plus y square. X square plus y square. Maybe if you want, you can put 2ay, or you can put y this side only, 2a. Now you do the differentiation. I think you can remove the differentiation of x square is 2x plus differentiation of y is 2y into dy upon dx is equals to 2a into dy upon dx. Now what you can do here, 2 will get cancelled in every step. Well, I will come after the class, man. So after this, what you get? X plus y and dy by dx is equals to a dy upon dx. Now from here you can get the value of a and substitute in this equation. Maybe you can call this as equation number 2. Get the value of a here. What will become value of a here? X plus dy by dx upon dy by dx equals to a. So get the value of a and substitute here, then simplify, so that your equation will not contain any a values. Okay. In the previous method, without expanding, if I do that, a value is not removing by substituting anywhere. So that's why what you do is we expand. Here I'll get the value of a. After getting the value of a, then I'll substitute in equation number 2. You may substitute in equation number 1 also, but your calculation is going to be a little bit bigger. Better you substitute here only. Then it can be simplified. Okay. Now like this, see here they substituted here only value of a. Then they got the final answer. So if you see any 9.3 questions, there are 12 questions. All the questions are of the same type. Form the differential equation of the family of circles touching the y-axis at origin. Just now we done circles touching the y-axis at origin. Okay. Next, form the differential equation of the family of parabolas having the vertex at the origin and axis along the positive y-axis. If it is along the positive y-axis, what is the parabola equation? X square equals to 4ay. If it along the x-axis, then y square equals to 4ax. Okay. Then form the differential equation of the family of the ellipses, foci on the y-axis and the center at the origin. In the previous example, we solved foci on the x-axis. Now the question is given foci on the y-axis. Just you have to refer the class 11th exercise or those chapters to get the general equation. Then you can solve them very easily. Next, 9th one is form the differential equation family of the hyperbolas. Then differential equations family of circle having the center on the y-axis and the radius is 3. Center on the y-axis is 0, a and r value is 3. So the same way of solving, this way only, 0, a, and instead of here radius I'll take it as 3. So the equation will become x square plus y minus a whole square equals to 3 square. Okay, so that's how we can solve it. So try these questions. If any doubt, next class we will discuss. Is that okay? Yes, everyone.